Okay guys, welcome back. What I'm gonna do right now, I'm gonna switch to the cloud. I'm gonna share with you my instance, then let's try to work and play around to see how can we play with the certificate authority. How can we create, for example, a request in order to build certificate authority. Then after that, how can we sign by ourselves? By the way, you can, sometimes we do this one in local network. For example, IIT, if they can create, or to say, certificate root, okay, and put the copy of this certificate root at every single machine, and we can sign locally, or let's say self-sign, or using this certificate authority, or let's say the root certificate authority, in order to sign all the certificate, which can be only can be, let's say, validated within the IIT. We do this one sometimes because we don't have create signed certificate authority by a third party. Then we're going to use this one online. It's going to be like offline. Or maybe you can do this one in order to test your system. Okay? Demo. I blame Justin because Justin keeping take computer science. Okay? So nothing there. So the first thing I need to do what? I'm going to use OpenSSL. OpenSSL is free tool that allow you in order to simulate the process. I'm going to create a certificate. Okay? So before I create a certificate, I need to create or send a request. It's called certificate signing request. Okay. By the way, I skipped one part, but we are familiar with this one. You said www.iit.edu. When you click this one, your website is going to send a request to the server and say, "Hi, it's me. I wanted to communicate with you. Please send me your public key." So that server, that website is going to send to your browser what? The certificate. Say, "Hi, it's me. This is my certificate." So your site or website or your browser is going to do what in this case? It's going to verify the signature of this certificate. Of course, we do have like preloaded what's it called, root certificate authority. Double check if you are confident with this one. Trust the public key. Now we're going to say, okay, great. I can use one. Encrypt to say send the nouns, or send to say establish the communication. I can send, for example, a session key. Your browser creates a session key. Then after that, encrypt it using the public key of the server that you received via the validated via the certificate. The other side, the only one can decrypt the communication, yeah, because he's the only one knows the private key that's associated with the public key. Now after this stage, both of us has a symmetric key with a session key available. Now we can use this one in order to establish the secure communication. That's what happened. Okay. So give me a second just to jump to the slide. I think you need to collect all the labs or demo that we did in one slide, I would say in one file or two files, in order to make sure that everyone can perform this operation. Anyway, in order to get the certificate, we have different types. One of them, the single domain certificate, which is only for this specific domain. You can say iit.edu. If this IIT has some subdomains, computer science, etc., then in this case, it's not, you have to go up. You have to go pay more or somehow to get the multiple domains. That's what I guess the IIT, they don't have this one. I know why the IIT, they don't have CS, and some websites is not secure. It looks like they didn't, maybe they have like, maybe they have multiple domains, okay, which included a set of domains. You can specify them, it can be as a subdomains. And we have another one that we have, I think you have to pay. It's going to be more expensive than the previous two, with wildcard. Any certificate, any website, it looks like you say star.iit.edu. So that means whatever website we have, whatever subdirectory is going to be there, it's going to be included with the certificate. With I doubt that we have this kind of certificate. Anyway, we do have like many validation levels. Okay, the first one, you can only validate that when you get the certificate. This type of certificate is just in order, for example, if you have blogs or let's say social media application or maybe personal website, the only thing you need to what? You have come up with a certificate that do what? That just guarantee that you are the ownership of this domain. Only. I verify that when you get this kind of certificate, I can take a look and say, okay, this certificate just tell you that the owner of this domain is Justin, for example, no one else. Nothing else. I cannot guarantee anything else. The other one, extended validation, which that one is going to have more details. It looks like in this case, the certificate authority is not going to issue this one simply to you. No, it's going to go through it, investigation about you. Take a look, your identity, whether the organization match official records or not. If he said, this is me, I'm owner of IIT.edu. or double check the check who's the owner of this domain based on document that in the official record. Okay, the physical location, for example. So to give you more details, more confident, if the company or whatever, the website or the server has extended validation certificates, so now have more confidence that you are dealing with a real entity and the real owner. And also they have, like, for example, you have a company that you can use, this website without any issues. How can you create that? The first one, you need to create what you call, as I mentioned here, a special request. We call this one certificate signing request. So that's me. This is my information. How can you collect this information and send it to the certificate authority? I said, those are my information. Please help me in order to generate or create a certificate in my case. So the simple thing, I'm going to use OpenSSL. And the OpenSSL, I just want to jump to the command here. I can use request, OpenSSL request. If you take a look here, you can go to this link, or you can just Google that. So this one, just OpenSSL. What I need here, I'm going to use request, okay? And the requests have many parameters. So I'm going to just type the command, OpenSSL request. I'm going to create a certificate, a new key, and I'm going to ask you, please generate, when you create this certificate request, I'm going to generate a new private key, okay? And I put this information in this place. So let me copy and paste here, okay? So OpenSSL request, that means you're going to create request, certificate signing request in order to ask the certificate authority. This is my information. So create a file, contains some information. You're going to ask you about many information they wanted to collect from you. Then it's going to be new. I'm going to create a new key. That means I have a new key here, okay? And no nodes, that means in this case, if the private key is created, don't encrypt the private key. Don't ask me to provide you with a secret phrase or password in order to protect or access the private key, okay? Then let's say I'm going to store this information in, let's say, Alice key or Alice private. When you enter here, did you miss something here? It could be check here. The copy paste is not good. Let's do this one again. I will create the second one here. Yeah, it looks like I missed something here. So anyway, this is a command. I will type the command here for your convenience. And OpenSSL request, that means I create a request. Okay, signing request to certificate. New key, and the key is going to use RSA, and this is a scientific key. Don't encrypt the key. Okay, display or put the key out in this file. And he is going to create the key. Then I'm going to ask you about some information. This information must be collected. Remember, we said you're going to send some information to the certificate authority. These are information that we're looking for. For example, the country, let's say US. What's a state? Say state of Illinois. Locality name, city. Chicago, then the company, let's say CS458 Limited. Okay, this is our company. Organization unit name, whatever, any information. What's the common name? Let's say CS458.iit.edu. This is a link, for example. Email address, let's say CS458, let's say iit.edu, whatever, because we are not gonna send this one to anyone, okay? We're just gonna create or sign it by ourselves. Do you have a password here? No. Enter optional company name if you want, whatever, and this is the information can be created. If you have a ls here, you're gonna the file is called here CS. Which contain all this information. Of course, we have the private key, then we generate a new key here. So now we take a look, how can we, let's say, of course, if you have a private key, you can generate this one. So different story. You can say, this is my key, private key, use in order to generate that. So how can we sign it? So let's go this one, give me a second, okay? I think I have the request here to how can we get the information, how can we get the content. that's stored there. I think because the format that's stored there is different. I think add minus text. If you try to this one, add minus text here. Let's do this one, try to do whether I'm being able to check the content or not. Let's say here, cat, for example, what the CSR here, text. Can I do this one? No? I think I have something because I think the content is different here. But I guess I did this one. Give me a second to check the right command that allow me in order to check this one. I think you need to specify the end file, the forward command, this will be clear here. If I said this, let's check here. Yeah, that's the command, the right one. That allow you to check the content here because you have different structure. So if you take a look here, the content here, you see what's going on. Actually, this one's gonna verify, take a look at the request, is it correct or not. You check this one, all the information, version 1, you see, give us the cheapest one. I mean, version 1, not too much information. All the information that we sign, we input here. I said the country, United States, Illinois, Chicago, this is the company name, this is the website, this is email address, etc. And here, this is the information about, then it will be associated. This is the public key, okay? And this is the sign of the public, signature algorithm. By the way, you can, when you send a request, you can't specify or tell the certificate authority, please use a specific hash function. You can't tell them. By default, you're going to use a SHA 256, but you can't tell them, for example, you have a different algorithm or the hashing algorithm if you're interested. Okay? So this is how can you take a look at the content here. Open as a request, text, no out, it didn't display the private key, and verify, I mean, the content tell me is it correct or not. So here it's going to make sure whether it's correct or not. Because remember, when you send the request, this one, we are going to sign it too. Because otherwise, someone is going to intercept the communication, then try to play around to modify that. Okay? So now we sign that. Let me go over because I didn't have time, so I need just to skip in order to weigh that. How can we sign it? The sign, I'm going to use what's called OpenSSL. Using the what's called the X509. So I'm gonna say generate a request and sign it. And in the signature you can have some details. Remember, this is the self-signature, self-signing. That means usually we're gonna send the request there to the certificate authority. But right now, this is the way how can we sign it by ourselves. Okay? So you write this one here. You see that OpenSSL request. Of course, if you have the request that we just created, we can do this one, but I put this one only in one line. So in this case, it's gonna do everything. Create certificate for me, okay, self-signed. So new key notes. This is the key out, put the key in this, create the key, new key, and store there. X509 this means signed, and you have to create a certificate. Here in the certificate, you can specify how many days this is going to be valid. There's many parameters, okay? But I am not going to go over them, at least just to give you an idea how can a certificate looks like on the side, and put this information or result into CS459 certificate. This is the one, this is the copy that we can generate. Here it's going to do 2 in 1, okay? It's going to repeat the same operation that we perform, collect information, then create or sign or create a signature of me. I can do the steps that I did before. This request that we send. If you assume that we send that request, the certificate authority is going to certify this request, the public key, and send to me. Self-signed, you have to do this one by yourself. Collect all the information against US. I will have some weird Illinois, whatever city, let's say Chicago. What is it? Whatever organization name. I don't. Well, whatever organization unit name, with a computer science, whatever. I just have fake names, okay? cs.it.edu, then the email address a@b.com, whatever information you're gonna send, okay? Now we signed, and you have a certificate. If you take a look here, ls, you're gonna say we do have a certificate key here. It's here. That's what the information that we're gonna use or receive, or the one that we're gonna send later. I'm planning to have maybe different or another tutorial. If I have a time, we're gonna try to use this one in order to say communicate. For example, Alice is gonna do the same operation, and Bob is gonna do the same operation. Each of them is gonna create its own certificate. Then they're gonna exchange. Then you try to extract the public key used in order to, for example, share secret key. So it's gonna be interesting. I will try to do this one during this weekend. Anyway, so this is a certificate. How can you see it? How can you look, or how can you verify the certificate makes sense or not? In order to certify, I mean, make sure this makes sense or not, to check the certificate that we have, you have the command here. I will send it to you, copy here. So in this case, OpenSSL X509. That means, okay, I need to check 509, certificate. The input, this is the file, and the text will be output or no out. For the rest, for the result, for the public key or the private key that's contains that. I hate that. Why do this one? Oh yeah. I'm blaming you because you talk about the computer science. Yeah, see? So here in the top here, it's gonna say what is gonna be a certificate here. Take a look here. Oh, version 3, thank you. The serial number, that's all the information that we talk about, the X50309, it's going to be here. This is the serial number. This is the signature algorithm used. You see that? Shala, blah, 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 whatever. Validity. Not before April, not after. Remember, we said what? The year we have a specific time, you said 365. So the validity of this one is going to be 1 year, starting from today. That's great. Subject, zeros, other information is going to be included. Whatever you include is going to be here. Okay, and this is the subject public key. This is your public key. This is the value of n. This is the exponent. This is the value of e. You see that we talked about this one before. We said encryption, public encryption scheme mainly going to use value of the e is going to be 65537 for simplest. Okay. Then here give you some extension. If they add something, you can add them here and here. The certificate authority, and this is the signature of the whole thing here. So the system can use this one in order to provide the signature, whether it makes sense or not, whether it's going to be valid or not. Okay? So that's all for today, guys.